Hello and welcome to another day of Python coding. This is 100 Days of Python and I'm Bill Mosley. If you want to access the entire listing of the 100 Days of Python, you can go to my website at bmosley.com/hdp. Let's get started on day 34. Today I thought it would be fun to play around with text and trying to make sense out of text. And so what I've got here are three different strings of text, and these are written at the fourth grade level, at the 10th grade level, and at a Ph.D. level. And they all discuss the same topic in the same kind of way, but using different levels of writing. And what I thought it would be interesting to do today is to see if we could come up with a function that will spit out some kind of a score, some kind of a numerical value that will appropriately rank the fourth, the 10th, and the PhD level writing as being different from one another, um, and get them in the right order. Anything beyond that is probably going to cross into a level of sophistication that we're not ready for yet. But I think using some logic and some basic text processing abilities, I think we can kind of get to a place where we can feed it each one of these strings and it'll spit out some kind of a score that will rank them appropriately. So we might want to use things like average word length or word count or some kind of a score that reflects word variety. So a lot of different uses of different words. Maybe sentence length is something that we're interested in. And so, all of those things we can measure if we use a little bit of logic and some text processing abilities. So that's kind of what we can do here. We may even be able to get at a sentence complexity by looking at commas in sentences. So all of that is stuff that we can think about. And so let's just start with some really basic functions that will do some analysis on the text. So if I say, let's start with something really simple, something that does word count. Okay, so word count obviously is something that we can ascertain by counting the number of groups of words here. And we've got to be a little bit careful because sometimes punctuation, if we're splitting these strings of text on spaces, then this could be accidentally counted as one word. So what I'm going to do is I'm going to need to clean out the punctuation and make sure also that I don't have cases where I have two spaces in a row. So we want to be very cautious there. And before I do word count, before I define that, I'm going to want to create another function that cleans out my text. So clean, and I'm going to call it clean punctuation, or I'm going to call it clean PS, punctuation and spaces. So I'm going to say str text inside there. And so what I want to do is I want to use replace. So I'm going to say str text equals str text self-assignment dot replace, and I want to replace every period with a space. And I'm going to do this now for all the punctuation I can think of. So I'm going to replace commas. I'm going to replace question marks. I want to make sure I'm accounting for all of the major pieces of punctuation. So I'm going to replace those. Let's go ahead and cover ourselves with parentheses as well, both left and right. So period, comma. We don't want an apostrophe because it'll split that into two words, so that's not good. Let's scroll on through here, and it'll be interesting to see how that will be handled. So we want to probably remove anything that's purely numeric because it's not really a word. So we want to kind of think through this stuff. We're looking pretty good. So what I want to do now is I want to replace anything that has three spaces with one space. And I also want to replace two spaces with one space. And I'm going to do that last one twice, because if I do that, then everything will be reduced down to no more than one space in a row. Okay, so I'm going to do that, and that will return str text. So now I've got my clean text returned. So I can use that function here in my word count. So the first thing I want to do is str text equals clean ps str text. So now I can split that. So I'm going to split it to li text equals str text dot split, and I don't need to provide it any parameter here because I'm splitting on the space, which is the default. So if I want now, I can do the length. Actually, I want to return the length of the li text. Now, I mentioned earlier the issue of numbers. So if I want to, I can make sure that I am removing any of those numbers by iterating through all of them. So I can go for str text for str item in li text if str item dot is numeric, then we want to remove it. So I'm going to say str. What I actually want to do here is I'm going to create a new list, li new, make it empty, and if it is not numeric, so if it is not equals false, then what we're going to do if it's not numeric is we're going to go li new append, and we're going to append str item. The nice thing about that is that it will give me li new here at the end, and it will give me the word count after those are removed. So if I say word count for, and I'm going to print that, I want to print the results. So print word count and str fourth. So let's print word count for all three, 10th and Ph.D. Okay, so we're going to print all of those. Let's run this. And okay, interesting. The word count here for 4th, 10th, and Ph.D. is 93, 91, and 91. So that's interesting because we've got the same number of words for those. So we can't really reliably use that, but we can probably use some other stuff. So we can keep our word count, but let's start thinking about what else. One thing that we probably are interested in is sentence length. And sentence length is determined by these stopping punctuation. So a period, an exclamation point, a question mark would be the end of a sentence. But I want to make sure that I can break up my sentences into into the similar parts using a single punctuation mark. So the first thing I want to do is I want to take a question mark, I want to take an exclamation point and convert those to periods. So let's do this. DEF sentence length, str text, and let's first convert our str text replace, and we are going to replace this with a period. And we are going to replace str text equals str text replace. We are going to replace question marks with periods. And now what that allows us to do is li text equals str text dot split on the period. So what that allows us to do then is return the average sentence length. So now what we need to do is get number of sentences, which is li text. It's the length of li text, which tells us the number of items in there. And then what we need to do is create a total of all of the sentence lengths. Okay, so the total of all the sentence lengths is just the total length of str text. So int length is the length of str text. So now average length is the number of total length divided by the number of sentences. And it shouldn't be a string. I don't know what I was thinking there. That should be an int. So we got to fix it here too. Got to keep my variable names according to their type. And then return FL average length. So let's see if we change this out and test this with our three variables. Let's see what the average sentence length is. Okay, now we're getting somewhere, right? So we have a 69.2 or 0.3 length for the fourth grade, and for the 10th grade, we have 72.1 and then 80.5. So sentence length appears to be an interesting thing, right? Maybe we'll do one more here. Let's go for average word length. So we're going to go DEF word length, and we want to make sure that we are doing the same thing that we did for word count, right? We want to clean these up. So we're gonna actually copy a lot of this first part, and we're going to use str text again for the internal text variable. And now li new is what contains the cleaned up, no punctuation, no multiple spaces, and no numbers. So it's the average word length So we get that if we have the number of words by counting, int num words equals length of li new, because that's the number of words in there. So now we can get the length of the total str text again. Int length equals len str text. And so the average word length, of course, is going to be the total length divided by the number of words. So return int length divided by int number of words. So let's see if word length has anything for us. So word length, and again, look at us. We've got word length varying for each one of those. So we're using average. On average, we're using longer words in the Ph.D. And I bet if we got rid of words like the and a and of, that difference would be even more pronounced. So let's see if we can exaggerate the word length a little bit by getting rid of those words. And we can tap into this part where they got rid of the numbers right here. We can say, or if or str item not equal to of. So let's repeat that now. And we'll go and a, let's do the also. So if it's not one of those words, then it gets appended to the new list, and let's see what that does. Oh, look at that. It reduces the difference between these two and exaggerates the Ph.D., which is really interesting. So without that, it was more evenly spaced between the three, and with it, it was a little bit more pronounced at the higher level, which makes sense because you can see here we've got more of these smaller words broken up by these really long words. So that's interesting as well. Now, one thing that would be interesting to do also is maybe take these words, take the significant words in the text, and you could take the average of the 5 longest words in the text. I bet that would be really interesting as well. So there's a lot of different things you can do with text processing that are really kind of based on very simple pieces, but if you put them together in creative ways and you use your imagination, you could come up with perhaps a singular function that produces some kind of a numeric idea of the complexity or the level of the text. I want to do one more thing, and that is to create one more function that returns the total length of the top 10 longest words in each sentence. And so to do that, I'm going to have to break each one up into words, and I'm going to clean up the punctuation using my clean PS script first. And then what I'm going to do is I'm going to sort those from longest to shortest, and then just take the first 10 in that list and glue them back together and measure the total length of that group. So a few steps there, but it's going to return the total length of the top 10 longest words in that sentence. So let's give that a shot. So I'm going to call this one DEF top 10 length, and it's going to take str text. And so the first thing we need to do is we need to clean the punctuation. So I'm going to call it str clean equals clean ps str text. That'll get rid of my punctuation for me. And then I want to break that up into a list, AR words equals str clean split, and we'll split that on the space, so I don't need to give that a parameter. And then what I want to do is I want to sort that from longest to shortest. And so I'm going to use AR words dot sort. Now, by default, sort goes from the smaller value to the higher value. So the first thing I'm going to do is go reverse equals true. But in order for me to sort them not alphabetically, but by length, I'm going to have to provide that with a key function. And this is a new thing for us. But up here, up by my utility functions, I'm going to create a quick function that just takes a word and returns the length. So df return length, and I'm just going to say string inside that. And all I'm going to do is say return len string. That's it. That's the shortest thing I can do in terms of a function. All it does is take a string and it returns the length of the string as an integer. And so what that does for me is it allows me to use this as a key function. So I'm going to say key equals retlen. And I'm not going to put the parentheses in there this time, because I'm naming the function, but I don't want the function to be called right here. So I'm not providing parentheses. And what I'm saying here is for each of these items, we're going to run it through this, and we're going to use the return as the key for sorting those words. So now those will be sorted from longest word to shortest word. And now I'm going to create an array of the top 10 equals AR words, and I'm going to start at 0 and I'm end at 9, which gives me the top 10. I'm using slicing here, not a comma but a colon in there. And then I'm going to take that AR top 10 and glue it back together using an empty string. I don't want to pad the spaces any. So AR empty string dot join and AR top 10, and I'm going to assign that to str top 10. And the last thing I want to do is get the length of that. So return len str top 10. So it's going to return the length of the top 10 words. So let's test that out by pasting it in here, and let's run that. Okay, and there we go. The length of the top 10, that's a wonderful indicator of level. So that is great. So now we decided that word count was too similar, not useful. These are kind of my utility functions. Word count, not super useful, but these three I think are pretty useful. The sentence length, the word length, and the top 10 length. Now, if you remember, the average word length looks like this. So I'm actually going to multiply that times 10. And so before I return that, I'm going to multiply that times 10. And I'm going to turn it into an int, which will just chop off the decimals. So when I multiply that times 10, it comes out to 50. And if I try that on all of them, it should give me enough of a difference. So this is sort of fine-tuning things so that when I put this together, so it gives me some difference. Not a ton, but if I use that in combination with some of the other things, we'll be in pretty good shape. So I'm going to create one more function, def. We'll say score level. And that's going to take str text, just like that. And I'm going to have it actually print out. I'm going to have it print out the score for each thing that it's given. So when I'm done with this function, it's going to give me a readout of the score. So it's going to say, I'm going to say FL, I'll say sentence length FLSL equals str text, sentence length str text, FL word length equals word length str text, and then FL top 10 equals top 10 str text. Now I'm going to add them together. So FL score equals FL SL plus FL WL plus FL TT. Now, in each of these, if I wanted to increase the factor or the weight of each of these, this is kind of where I could do that. Right now, I'm just going to give them equal weight, and we'll see how this goes. So we are going to now print out the score. This text has a score of FL score. And I think what I'm going to do is I'm going to add a label up here. str label, the str label text. Okay, so there is this. And let's give this a shot here. So we don't need to print anymore. So I'm going to say score level, fourth, and str fourth, score level, 10th, and str 10th, and score level, Ph.D, and we have str Ph.D. Okay, so when I run this, it should give me my relative scores in a friendly format. Look at that. So maybe not scientifically accurate, but it does give us some idea of what we want these things to look like. And of course, it would be nice maybe to come back here and drop that down to 2 decimal places. And so that is a very non-scientific but interesting way to use text analysis and text manipulation to get an idea of the various levels of writing present in different groups of text. So that was kind of a fun exercise and hopefully useful for you. Join us next time on 100 Days of Python. And this has been day 34. Once again, if you need access to the entire listing, there's a link below in the text, or you can go to bmosley.com/HTP. See you next time.